In this video today, we're going to talk about acids and bases. So let's start off with this question. What are some common household substances that are acidic? And what are some of the common household substances that are basic? Why don't you hit pause now and think about that, make a list of what you think some acidic substances are and some basic substances are. Okay, and hopefully some of the things you came up with that are common household substances that are acidic would be things like lemons, limes, citrus fruits that have citric acid in them. Maybe vinegar comes up, battery acid like sulfuric acid in a car battery. So things that are basic. Drain opener is basic. Cleaners in general are kind of basic substances. So they are relatively common things, acids and bases. But let's look at what we're planning on doing here. We need to be able to identify an acid or a base by its structure, by its formula, and then we're going to use some equations involving acids and bases. But first, let's talk about the assessment tomorrow. We're halfway through the chapter roughly. Remember, this one's broken up into 2 assessments, so this is a pretty short assessment. 5 multiple choice questions, 3 equations where I give you the reactants and you complete the reactant and identify what the precipitate is in it, and then 2 where you write the ionic and net ionic equations, and then 1 where you write the molecular ionic and net ionic equations if I just describe it to you, so just one of them where you have to change the formulas, and then finally 2 acid-base reactions. As you're going to see, acid-base reactions are fairly simple reactions. All right, so now is the time to think about and to discuss among yourselves what questions you might have had about the reading, about what we had done the previous day, which was to talk about ionic and net ionic equations. So take a moment and talk about that. Okay, so we're going to kind of continue in this ionic net ionic equation concept a little bit today, and use that a little bit in what we're doing here with acids and bases. Let's start off with where acids and bases fit into the general scheme of things. You may have remembered we had the term electrolyte back on the first day of the chapter. An electrolyte is something that, when you dissolve it in water, conducts electricity, and they can be divided into 3 classes. There are salts, and most of what we've been doing so far in this chapter has been dealing with salts. This is not the use of the word salt like we talk about at the table to put on our food. This is a chemical class of compounds. And then there are bases and there are acids, so that's what we're going to talk about today, specifically acids and bases. All right, let's start with acids. As I mentioned earlier, citrus fruits are something that is acidic, and they have some of these characteristics. If you taste them, they taste sour. And yes, that's true of even chemical acids, ones you pick up in the laboratory. They do taste sour. They also do damage to your tongue, but they would taste sour. Some examples of acids you might find in the laboratory: hydrochloric acid, sulfuric acid, nitric acid. And according to the Swedish chemist Svante Arrhenius, an acid is defined as anything that produces hydrogen ions when you put it in water. So if you notice these acids, they all start with hydrogen because, according to Arrhenius, those hydrogens come off and become hydrogen ions when you put them in water. And finally, the term strong refers to something which completely ionizes in water. It has nothing to do with how corrosive an acid is. It has to do with how well it ionizes in water. These are all strong acids I've given you here. The acid in a citrus fruit is not a strong acid. Okay, we're going to end part 1 here, and we'll pick up with this in part 2.